Hello everyone. In today's video, we will be learning about datagram packet switching and virtual circuit switching, and will also perform a Cisco packet tracer simulation to understand how it works in real time. Let's begin with a short introduction of datagram packet switching. In datagram packet switching, data is divided into small packets, each sent independently throughout the network. Each packet carries its own destination address and may take different routes to reach the receiver. There is no fixed path or prior connection, making it fast, flexible, and efficient for bursty data. Commonly, it is used in the Internet IP networks where packets are assembled at the destination. Now let's move on to our Cisco Packet Tracer simulation. At the bottom of the Cisco Packet Tracer window, we can see various options such as network devices. So under the network devices, we have many different types of routers and its models. Then under the end devices, we have different devices such as PCs, laptop, server, tablet, phones, TV, etc. Then under the components, we have the MCU board, PVC board thing. Then under the connections, we have different wires which can be used for the connections. So the wire which is used for connecting the PC1 to router 1 is nothing but the copper straight through wires, and the wire which is used for connecting the router and the router 1 to router 2 is nothing but the copper cross over wire. Now let us see the information of each of the devices. So when we move the cursor to PC1 here, then we can see the information of each of the device. So the device name can be seen as PC1. The device model is PCPT, and the port which is used is fast Ethernet 0, and the link is up. So when the link is up, it means that the connection is successful. And the IP address which is used here is just the IPv4 address and not IPv6 address. Similarly, when we move on to the router 1, we can see that the device name is 28 router 1 and the device model is 2811. So when we move the cursor to router 1, here we can see that the port used is fast Ethernet 00 and fast Ethernet 01, and the link for both is up, which means that the routers are connected successfully. Similarly, when we move to router 2, we can also see the information of each of the routers. As you can see that the port here used is fast Ethernet 00 and fast Ethernet 01, and the link for both is also up, which means that the router 1 and router 2 is connected successfully. Similarly for the router 3 as well as router 4. And then finally, we can see the information of PC2, which is considered as the destination, and here PC1 is the source. Now, when we click on PC, a separate window opens. Inside the desktop, we have options like IP configuration and command prompt, where we can verify the IPv4 settings and send ping messages. Similarly, when we click onto the route, we get to see its physical structure, internal modules, and the network interfaces it supports. Here we can see that there is an option called as real time, which basically means this is the space where we can use, which will be used for connecting the devices, that is PC to router, router to router, also from PC1 to PC2. That is nothing but the source and the destination. Then we also have another option called as simulation. When we click on to the simulation, so when we click on this play button, the simulation will start. So here we can see that the PD moves from source 1, PC1 to router 1, then from router 1 to router 2, then the PD moves from router 2 to router 3, then the PD moves from router 3 to router 4. So here we can observe that the datagram packet switching breaks data into small packets that travels independently throughout the network. There is no fixed path. Each packet may take a different route based on the router decisions.
Now let us move on to virtual circuit switching simulation. So here there are two devices, that is nothing but the PC1 and PC2. Here PC1 is the source and PC2 is the destination. There are two routers which are used here, router 1 and router 2, each of the model 2811 and 2811 as well. So there is a frame relay switch which is connected between the router 1 and router 2. So the wire which is used for connecting PC1 and router 1 is nothing but the copper straight through wire, and the wire which is used for connecting router 1 and frame relay switch is serial DCE, and the wire which is used for connecting frame relay switch to router 2 is nothing but the serial DCE. And again, to connect router 2 to PC2, the wire which is used for connecting is nothing but the copper straight through wire. When we place the cursor on frame relay switch, we can see the information of it. So here the device name is FRSW and the custom device model is 2811 iOS 15. The port which is used to connect the frame relay switch is fast Ethernet 00, fast Ethernet 01, serial 000, serial 001. And the link for fast Ethernet 00 and fast Ethernet 01 both are down, which means that they are not connected successfully. The link for serial 000 and serial 001, the link for both is up, which means that the frame relay switch is connected successfully to router 1 as well as the router 2. And the IP address which is used here is IPv4 address and not IPv6. Here real-time option, it is nothing but a working space where you can make many different connections. Then we have a simulation option. So in order to begin our simulation, we need to click on the play button in order to start the simulation.
If we start the simulation, we can see that the PC1 sends the packet to router 1, which basically means that there is a predefined path which is assigned to each of the packets and hence moves in a predefined path and not anywhere else.
So the difference between the two packet switching observed is in a VCS we use a frame relay switch, whereas in DCS only the routers and PCs are used. So now let's know about frame relay switch. Frame relay switch can indeed be used as a technology that implements virtual circuits. Frame relay is a wide area network that is nothing but WAN protocol that operates at the data link layer 2 of the OSI model. It is based on virtual circuit switching, meaning data travels through logical paths, virtual circuits established between endpoints before the transmission.
Now let us know the differences between DCS and VCS. First, DCS is connectionless while VCS is connection oriented. Second, in DCS, each packet can take a different path, but in VCS, all packets follow the same fixed path. Third, in DCS, packets may arrive out of order, whereas in VCS, they arrive in order. And finally, DCS doesn't require any kind of setup, but VCS requires a setup before the data transmission. Now let us know the differences between a router and a frame relay switch. First, a router routes data between different networks while a frame relay switch switches frames within a frame relay network. Second, a router works at the network layer, layer 3, and a frame relay switch works at the data link layer, layer 2. Third, a router uses IP addresses, but a frame relay switch uses data link connection identifiers. Fourth, routers choose the best path dynamically using routing tables while frame relay switch uses predefined virtual circuits. Fifth, Routers don't need manual setup, but frame relay switch requires a setup before communication. Sixth, routers perform error detection and correction, whereas the frame relay switch does minimal error checking.